Welcome you all in my channel Chemistry, the Mystery of Molecules. So today's topic is redox, means reduction and oxidation. So before going to main topic, what are today's points? First, redox reaction, then oxidation state, oxidation of covalent compound and ambiguity about hydride, oxidation reduction versus covalent compound, and intermediate oxidation state, and finally we will discuss about its future. So from basic to application, everything will be covered. Now before going to details, one MCQ. What is the oxidation state of iron in the two complexes? 4 options are provided. Please pause the video and write your answer in the comment box, and definitely at the end of the discussion you will have your answer. Let's start. What's redox reaction? Redox means both reduction and oxidation combined, this process. So it's a type of chemical reaction in which oxidation states of the atoms are changed by exchange of electron. Redox reaction are characterized by actual or formal transfers of electron between chemical species. Like in this case, you can see sodium reacts with chlorine and produces sodium chloride. Although please don't try this reaction because this reaction happen violently. These are very reactive reagent, and here 2 sodium reacts to produce 2 sodium chloride. But in this case, sodium gives 1 electron and converted into sodium plus electron, and these electron taken by chlorine and chlorine converted into Cl minus. Consequently, in this way, and these 2 ion combines form this actually ionic compound, which is sodium chloride. Okay, so in this case, the definition of oxidation is removal of electron or addition of oxygen or halogen or other electronegative atoms, or increase in oxidation state. So what is oxidation state will come, or in case of reduction, addition of electron or addition of hydrogen, or decrease in oxidation state we will come. So in short, you may consider such kind of chemical reaction as the consequence of electron exchange. So you may consider in overall reaction there are 2 types of reaction possible. One is redox, another is acid base. Now let's go into details. What is oxidation state? Oxidation states are, or oxidation number is the hypothetical charge of an atom if all of its bonds to different atoms were fully ionic. Okay, so it describes the degree of oxidation, or means loss of electron or of an atom with a chemical compound. Conceptually, the oxidation state may be positive, negative, or 0 possible. While fully ionic bonds are not found in nature, many bonds exhibit stronger ionic or weakly ionic, like that, making the oxidation state useful for the prediction of their charges, but it has some fallacy also which will come. Atoms having oxidation state but ions have charge, it may be same or may not be same. What do I mean? For example, in iron 3 plus ion, the charge is plus 3 unit and oxidation state both are actually plus 3. But for perchlorate, if you look, then oxidation state of this central chlorine is plus 7, whereas the oxidation state of oxygen is minus 2, but the overall charge of this ion is minus 1. You can see chlorine is plus 7, oxygen is minus 2, but overall group has minus 1 oxidation state. So that's the thing, it may not be the same, means oxidation state and overall charge of the moiety. For understanding, you may consider that oxidation state means electron density around the metal, then it will be more accurate. And oxidation state means positive oxidation state means less electron density, or negative oxidation state means more electron density. So positive charge or positive oxidation state means less electron present. So that's a relatively more accurate. So based on this statement just I told, we can conclude that atom having higher oxidation state or oxidation number is tendency to gain electron, because its electron density is less around the metal. So if electron density is less, its tendency to gain electron density will be more. it will act as oxidizing agent. And what happened? Oxidizing agent oxidizes other, but itself got reduced. Similar thing is observed for atom with lower oxidation state, and it will try to donate or lose electron because it is already in excess of electron. That's why they are considered as reducing agent. Now, example is that same perchlorate ion. It is an oxidant because the central chlorine is in +7 oxidation state. So central chlorine have very less electron density because there is a chlorine oxygen bond. Okay, but if you look at overall ion, this is actually a negative charge. So this oxidation state describes the element properly, whereas the charge describes the group or ion properly. Now, so we understood that it can act, oxidation state is +7, but it is actually deficient of electron. It has a tendency, it takes electron, consequently it acts as an oxidizing agent. Okay, so this thing we understood. Now, so from based on our understanding, removal of electron or addition of oxygen, halogen and electronegative, okay, fine. Reduction, addition of electron, addition of hydrogen is reduction. Now, if I say addition of oxygen is called oxidation, then if you react oxygen with fluorine, it produces, for example, OF2. So in this case, oxygen is oxidized or reduced. Actually, tendency of oxygen is itself, means it takes electron, got reduced and it oxidizes, but this is exceptional example because oxidation state is 0 here. In this case it's -2, sorry, it's +2. Why? Because fluorine is more electronegative element, so fluorine itself oxidizes oxygen. This is an exception, please remember. Not only that, if we react, for example, two halogens and produce another different ICl, interhalogen compound. In this case, for example, halogen addition, for example, you react Cl and I2. I am talking about hypothetically. So in which case, what you say, which one got oxidized and which one reduced? And another thing, they are not same, because if I say carbon carbon bond, okay fine, same element, we don't consider. Nitrogen nitrogen bond, we don't consider. But what about heteroatom? And this is actually polar. So in this case, concept comes about electronegativity. We shall come. Now, the next question, what is the driving force for this oxidation and reduction? This is to achieve the nearest noble gas electronic configuration, and that is, for example, we say octet fill up, and for hydrogen means for hydrogen helium, I'll come, it's a doublet, 2 electron, this thing. For other transition metal, 18 electron, there are many things. So in tendency to get stabilization on mainly octet fill up, such that they get more stability, and this way they form ions with opposite charges and form ionic compound. For example, sodium plus having 8 electron in its outermost valence shell, and chlorine minus having 8 electron on its outermost valence shell. Consequently, they are stable, they compound and they produce sodium chloride, which is ionic compound. Now, question is the oxidation or reduction applicable only for ionic compounds? Because I am giving example of ionic compounds. What about for covalent compound? Because we know there are more covalent compound compared to ionic compounds. How to calculate those? So now oxidation reduction in covalent compound. Actually, for covalent compound, ions are not obtained directly. In fact, huge number of inorganic compounds are not purely ionic too. That's the interesting point, student. Consequently, the electronegativity difference is the main factor to decide the oxidation and reduction process. Let's come to this example again. See, oxidation state in case of oxygen was +2, fluorine was 0, it is -1, 1, so 2. So in this case, who is reduced? Fluorine is reduced, but oxygen got oxidized. Exceptional example. If I look about this example, iodine plus chlorine, iodine has +1 oxidation state, chlorine is -1, because chlorine is more electronegative. So this is a useful, better to say more easy way to explain those intermediate compounds. Not only that, carbon based chemistry, if you check for bonds between same atom, or number or multiple bond doesn't encounter the change in oxidation state. For example, if I say nitrogen nitrogen triple bond, you will say no issue, 0 0. If I say fluorine fluorine single bond, 0 0. But what about carbon carbon single bond? 0 0 element, no issue. But in this case, if I say this is actually benzene, means there are 6 hydrogens attached to these carbons. Now in this case, if you check the oxidation state, this all carbon have oxidation state -1 and hydrogen is +1, because carbon is relatively more electronegative compared to hydrogen. So it's a very low polar, but this difference is there. So now you will say that, sir, you are stuck. In this case, you can see that there is one double bond, one single bond. Still, it doesn't matter. Oxidation state is same. But you can say here that, sir, in benzene, you can't distinguish the double bond and single bond because it's completely delocalized. So this is not a perfect example. So perfect example you can consider, this is actually propene. In this case, this is sp2 and this is sp3. This is also sp2. Now the oxidation state is determined based on these hydrogens. In this case, the oxidation state is -3, this carbon. In this case, oxidation state is -1 because one hydrogen attached. In this case, oxidation state is -2. So from here also you can understand that carbon carbon multiple bond doesn't involve into the change in oxidation state or number. The substituent matters. Not only that, if you look at this acetic acid, sorry, this carbon is -3, whereas if you look at this carbon, this is +3. Why? Because carbon is more electronegative than hydrogen. Consequently, this is -3, whereas it is attached to oxygen. So this oxygen is more electronegative to carbon. That's why this is +3. So interesting. So for that purpose, student, I believe you should have a good idea about periodic table, and otherwise after some time I shall explain you. Now the question, as I told, that is hydrogen addition is oxidation or reduction. Based on our previous knowledge, we say, sir, it is reduction. Sometime before you told, but student, actually it's called the development of science. When we encounter some difficulty, some problem, some limitation which doesn't fit to our formula, then we think what is our mistake and we try to understand the concept elaborately, and based on that we can say hydrogen addition is actually, we should not conclude instantly its reduction. We should focus on the electronegativity difference. That is the main tool. So we should have a clear-cut concept, and I believe some memorization about electronegativity, because it depends on the nature where the hydrogen atom got attached. For example, if you react this sodium with hydrogen, it produces sodium hydride. It's actually ionic hydride. You will form Na plus and H minus. H minus means it has 2 electron on its outermost valence shell, and this is another kind of stabilization for first row element. Okay, means helium configuration. And you will say that, sir, you are saying this should be stable helium configuration, but this hydride is not stable. But there is an example, student, lithium plus. It also have 2 electron, means 2s2, but this is stable. Okay, fine. If you look at ammonia, means reaction of nitrogen and hydrogen produce ammonia, where there are nitrogen hydrogen bond, and this ammonia, this thing called covalent hydride. But in covalent compound there is a word polarity. We shall come. Now just check, this is ammonia, fine. There is a boron and methane. If you look at that polarity of this nitrogen and hydrogen, nitrogen is delta negative, hydrogen is delta positive. In case of boron, it's reverse. Please remember, hydrogen is delta negative, boron is delta positive, because boron is relatively slightly more electropositive compared to hydrogen, and carbon is slightly more electronegative compared to hydrogen. That's why carbon is delta negative, and in this case hydrogen is delta positive. Just some time before I have shown. Now there is a difference. See, in this ammonia, this polarity is significantly higher. Why? Because the electronegativity difference is the reason of the generation of polarity. Whereas, so more electronegativity difference, more polar bond. Less electronegativity difference, less polar bond. So this NH bond is more polar, whereas the CH bond is very less polar. Please remember this thing, and that is the reason where it is said that hydrogen bond between phon means fluorine, oxygen and nitrogen have attached can form hydrogen bonding with any means compound, or this phon attached to hydrogen is eligible for hydrogen bonding. There are very few exceptions, but please don't forget about these exceptions. They are capable to form hydrogen bond, whereas methane can't form hydrogen bond because the polarity of the bond like carbon and hydrogen is very less, that it is not capable in producing hydrogen bonding. Actually, there is one exception, this aldehyde hydrogen. The aldehyde hydrogen can form hydrogen bond. Professor Desi Raju have some research on this, so that's a exceptional case, student. For basic study, I think it is better to avoid. Remember about this phon story. Now, that's why the question, why does hydrogen bonding is observed in ammonia but not observed in methane? Now, let's look at the periodic table little carefully. So, if you look at this side, elements are electropositive, means they have a tendency to give electron, form ionic compound. This side negative, they have a tendency to take electron. Extreme, they both are actually extreme character, they both have, but in between, in this case, electronegativity difference. Now let's look at boron, carbon and nitrogen. Hydrogen have electronegativity 2.2, boron 2.04. Consequently, boron is more electropositive. Now, if you look at carbon having electronegativity 2.55, that is more or higher than 2.20. So that's why carbon was delta negative here, you can see. Next, nitrogen electronegativity 3.3. So that is significantly more, 2.202 this. Now if you look at the phon elements, if you look at this phon elements, means this carbon, sorry, not carbon, this is actually this nitrogen, oxygen and fluorine, this part if you look at. So in this case, nitrogen 3 electronegativity, oxygen 3.4 and fluorine 3.98, means near about 4. So extremely high difference of electronegativity with hydrogen. That's why their bonds, this nitrogen hydrogen bond or this oxygen hydrogen bond, this fluorine hydrogen bond, are very high polar. That's why they are capable to establish hydrogen bonding in any cases. I guess you have understood. And rest elements are decided based on the electronegativity differences. So this is for basic understanding. We'll stop here. Now, an interesting concept: if an atom has multiple oxidation state, and what about the intermediates? Like electron rich substrates act as reducing agent, or electron deficient substrates act as oxidizing agent. In between substrate means they are neither electron rich nor electron deficient. So they can act as both oxidizing or reducing agent depending upon the nature of the counterpart. Means one part needs, means for example, you have someone who is very much hungry or very much needy, but you are not that much rich. So compared to you, that person is deficient. So you can give someone, or you go into another someone who has excessive wealth, extremely rich, but you are not rich, not poor in terms. So you can take. So you are in between phase. Rich is one person, another one person is poor, and you are in between. So I am talking about you. Let's understand what is the example of you. Can a compound act as an both oxidizing and reducing agent? So it is actually possible. Compound having in between oxidation state and compared to its stable oxidation state, like hydrogen peroxide explained for some time, or conjugated compounds or delocalized compounds like porphyrin. Let's come to the first example, hydrogen peroxide. In this case, the oxidation state of oxygen in hydrogen peroxide is -1. Both are, because as I told, same atom bond doesn't contribute. Why -1? Because it's attached to one hydrogen, which is +1+1. Now it is in between, because oxygen could have three oxidation state. One is 0, elemental oxygen, one is -1, we are observing here in hydrogen peroxide, another is -2, for example in water. Okay, so now if you have a very strong oxidant there like potassium permanganate, why I am saying it's a very strong oxidant, because manganese center is +7 oxidation state, extremely electron deficient, so it can take electron from this hydrogen peroxide and oxidized it in oxygen atom, where the oxidation state is 0. So in this case, hydrogen peroxide got oxidized. Whereas if you react this with iron 2+, we know that iron 2 oxidation state means very common, iron 2+ to iron 3+. Okay, and in this way one electron is produced, and these electron act as reducing agent. We know electron as the reducing agent. As I told, the best definition of redox is electron taking or giving. Who takes electron is reduced, who gives electron get oxidized. So in this way, this iron center got oxidized and this oxygen got reduced. Because oxygen stable oxidation state is -2, but it is in -1 oxidation state, so it can take more electron and from water. So you can understand, based on your counterpart, either permanganate or iron 2+, it can act as both different types, means it could be oxidized or it could be reduced. Since this second reaction is like a Fenton type reaction, I think you have seen this. Okay, now let's come to the second example, that is porphyrin. This ring is observed in hemoglobins like iron porphyrin complex. If you look at this porphyrin little closely, they are actually aromatic, it's true. Now, but many double bonds are in conjugation, so huge amount of electron are delocalized to provide its aromaticity. It's a conjugated molecule. Okay, and it actually, since many number of electron there, it can act as electron reservoir. Why? For example, what we say as reservoir, for water reservoir, means it can store water. It has significant amount of water. What you can, when you have excess water, you can store in the reservoir, or when you need, you can take from the reservoir. So it is like electron reservoir, means it can take electron or it can donate electron, and that's property also helps for this iron porphyrin complex to be redox material in our body. For example, cytochromes. Cytochromes are redox enzyme in our body, and why they are capable to do this? Because the oxidation state of this iron could be changed, and not only iron, this iron ligand complex is actually responsible for its redox behavior. Okay, now let's come to the advanced level topic, future oriented solution by the use of redox. What? For example, application of this redox system in future fuel generation like photochemical water splitting. Please look at the molecule water little carefully. This is the molecule of water. We know it's a bent molecule, and if you look at the oxidation state, oxygen's oxidation state -2, hydrogen having oxidation state +1. So if I say water oxidation, means can I oxidize hydrogen more into +2? Obviously not possible, because maximum hydrogen do not have any electron. What it will give? Not possible. So which center I can oxidize? I can oxidize this oxygen center into either hydrogen peroxide, that is -1 oxidation state, or oxygen gas. By the way, there are some example of water to hydrogen peroxide, but I am not going to this is an exceptional thing, research topic. But our main topic of discussion is water to oxygen, because in this case oxidation state becomes 0, neutral. So this is actually a oxidation. So what reduction could be possible? Because when somewhere oxidation is happening, In counter to that, some reduction will happen. In this case, hydrogen is +1 oxidation state, so it could be reduced to hydrogen gas where its oxidation state 0. So this is actually, you can consider reduction because decrease in oxidation state. We understood? So this thing we are going to do using a photo light, irradiance, sunlight you can consider. Okay, so in presence of sunlight we utilize semiconductor. So these are actually semiconductor. So what they do, this in presence of light, hole and electron. Hole means you can consider electron deficient species, and electron, you know this, and electrons are reducing agents. So means where the electron will attack? Electron will attack on this hydrogen because this hydrogen will be reduced, H plus will be reduced to this hydrogen. So consequently from water hydrogen is produced, and this is called the conduction band. I am not going this thing. So this water will be reduced into hydrogen, and who will oxidize? Because hole, previously this catalyst was electrically neutral, now you have generated electron, means electron rich species, then there will be electron deficient species, this is hole. So if electron is responsible for reduction, then hole is responsible for oxidation. So whom it will oxidize? As I told, this water oxygen to oxygen gas, and that's why it produces oxygen. So this is a photochemical fuel water splitting. Now why I am saying it's fuel generation, because we know that water is a very stable molecule, that's why oxygen and hydrogen react and produces water. Okay, so this thing we know, and it produces along with that huge amount of energy, because water is a very stable molecule. So if you want to do the reverse reaction, means water to oxygen and hydrogen, then you need to give energy, and this is, you can say, it's a chemical energy storage. What energy? This solar energy into stored in chemical bonds. And how we can utilize? We can utilize this energy by fuel cell type setup, where oxygen and hydrogen will react and produce water, and along with that we will get energy when we need. For example, we are running a car using hydrogen as a fuel, and it allows to react with air. Air means aerial oxygen, and in that case it will produce water in the exhaust, very clean, zero emission product, and along with that energy will help us to drive a car. You may consider this thing as a hydrogen fuel cell based car. Not only this, hydrogen could be utilized for other purposes, like in our fertilizer industry, this thing. And remember, this hydrogen thing is getting huge attention in future, because we are trying to replace carbon dioxide because of its global warming potential or greenhouse effect. So hydrogen could be the future fuel, and nowadays oil companies worldwide investing huge amount in hydrogen research as their future business. So we have understood this part. Second thing, CO2 reduction. Why CO2 reduction is important? We know that we have burned huge amount of fossil fuel, and we have emitted huge amount of carbon dioxide, extra carbon dioxide I would say, into the atmosphere. So presence of this excess carbon dioxide is responsible for global warming and climate change. Already we have increased our global average temperature 1.2 degrees centigrade. We can't go. In recent COP26 meeting, we promised that we will keep the rise up to 1.5 degrees centigrade, or in Paris Climate Agreement, we told that we will keep it up to 2 degrees centigrade. We'll arrest the rise. So it is essential for CO2 separation, CO2 elimination from the atmosphere. Till now, we are adding huge amount of carbon dioxide in, or better to say, we are dumping huge amount of carbon dioxide into the atmosphere on a regular basis in order to generate energy for our day-to-day use. So for that purpose, we are adding CO2 into the atmosphere. Now there are some technologies using that you can separate CO2, or I would say best is plant more trees and don't destroy forest. Deforestation it should be considered as a crime without proper justification. Now, so this CO2 is the problem. So we can separate CO2 by technology, but we need to fix it. Trees are the solution. Not only that, but also we need to use some other tools to utilize this carbon dioxide to prepare something else such that they could be separated from the atmosphere. For example, you have separated carbon dioxide from the atmosphere and stored somewhere in this carbon dioxide form, so it can come out and pollute, and this is a huge amount of carbon dioxide, student, in gigaton scale. Okay, so it's a huge. So for that purpose, if we are able to convert this carbon dioxide into some useful chemical, that's the best. And here one strategy, this is graphitic carbon nitride and means semiconductor, this is another semiconductor, I am not going details. So what happens in presence of sunlight, what it does, as I told, hole and electron. So upper is electron and lower is hole. So hole is oxidizing, electron is reducing. We know that hole is capable to oxidize water into oxygen. Just some time before you have seen the hole is electron deficient and it will take electron from oxygen which is in -2 to oxygen 0, fine. Now where the electron will be given, instead of proton it can give the electron to carbon dioxide, because in carbon dioxide molecule the central carbon atom is +4 oxidation state. So it's highest oxidation state of carbon, so it can accept electron, it takes, and it is capable to produce carbon monoxide. And what is the beauty of this? This carbon monoxide can react with hydrogen and produce methanol. Already technology developed, we need to implement in its massive scale. I have already discussed a dedicated video, and these methanol is, student, is a green fuel. For example, the cities like Delhi, Bangalore, they are landlocked cities, they got huge amount of pollution yearly. So if we replace the petroleum for those transport sector in those places, then the pollution intensity could be reduced and people's life could be saved. So that's why such kind of research is also important, that is carbon dioxide reduction and fuel generation. So let's come to our MCQ. What is the oxidation state of iron into two complexes? Here if you take K4FeCN6, so in this case if you see the carbon, this cyanide is actually a negative species cyanide anion, so overall complex is neutral, means this FeCN6 is having a 4 unit positive charge because potassium is 4 plus. So now my 4 unit negative charge, and there are 6 unit negative charge possible for this cyanide. So how many positive charges contributed for iron? 2 unit. So iron oxidation state first would be +2. And if you get this answer, then automatically one option left, you don't need to think, because you people may say that, sir, I don't know about this compound, or you haven't read. See, you don't need to think about this if you can use your common sense, and that's why practice needed. Please study carefully. Now you can understand this is. Now a question, how this is negative? This is actually K2 means 2 plus, so iron tetracarbonyl, this thing having 2 negative unit, 2 minus. Now we know carbon monoxide is a neutral molecule, it can act as a ligand. This, it's a neutral molecule. So what is the oxidation state of iron? -2. I know some people will say, sir, oxidation state of a metal is -2. Is it really possible? Yes, student, possible, because first of all iron is transition metal, point number 1. It has a wide range of oxidation states. Second, you will think that, sir, huge amount of electron density on iron, fine, but it is attached to carbon monoxide, which is actually a pi withdrawing ligand. So this carbon monoxide withdraws or delocalizes the excess electron density from the iron center to this ligand, and delocalization of excess electron is indicating stabilization. So it is there. So that's why the right answer is option C. Okay, so this is the end of the discussion. Thanks for watching. If possible, please visit my another channel, Climate and Chemistry, and subscribe it and encourage me. Thank you again. See you in my next video. Bye bye.